Okay, so, yeah, recording. All right, so we have two jars here. All right, so in these two jars, we've got some marbles and some magnets. And so what I'm gonna do is I'm gonna kind of shake them up a little bit and we're gonna see what happens. You could probably kind of make some predictions, right? What do we think is gonna happen when we shake the marbles up? What are they gonna look like? Okay, let's find out. Yeah, so they kind of flew everywhere, right? They all kind of moved on their own randomly all throughout the container, right? Let's try the magnets now. I'm gonna try and shake them with the same amount of strength. Okay, well, that's pretty different, right? So two very different things happened. These kind of went crazy all over the container. This, the object was moving around, but all of the magnets, all the pieces in there stayed together as one object, right? So why is that? What is the difference, right, between these two objects? What's going on with the marbles versus the magnets that they acted completely different, even though I was shaking them the same amount? So some of you are probably saying, well, these are magnetic. Okay, that's fine, but what does that mean? What does that mean for each of those individual objects in there? It means that they're attracted to each other. There's some weird force that keeps those things stuck together, right? Almost like a glue, an invisible glue. So there's something in there sticking all of those magnets together, whereas the marbles don't really care. They don't really have anything keeping them in one, piece, right? They kind of just separate freely. So the big difference between these is that there's something attracting those to each other, and there's nothing attracting these to each other, okay? And so these spread out freely, these stay together as one solid object. If that makes sense to you, you actually understand the concept of intermolecular forces. So if we go over here, right, you might have seen a diagram like this before, right? We have particles and molecules, and what happens is there's different states of matter they can be in, right? Gases, these are kind of going crazy, floating around freely, filling the container. What does this remind us of? Well, this was how our marbles were behaving. This is how they were acting. They were acting like a gas. Whereas our magnets had a really strong attraction to each other, and they kind of stayed as one piece, right? And so they were acting kind of like a solid did. So why is that again? Again, it had to do with how attracted each marble was to another marble and each magnet was to another magnet. Molecules are the same way. They have the same attractions. So before, back in the day, you might have seen this with water and be like, okay, well, if you have a little bit of heat, water is solid ice. If you have a medium amount of heat, room temperature, water is a liquid. And if you get really hot, at a lot of heat energy, we can get water to separate and become a gas and boil it into a steam. Well, I shook those containers at about the same strength. And remember, heat is just moving particles, shaking the particles. And so we can see that some things can be a different state of matter, even at the same temperatures. Let's look at this breakfast of champions I have here right now. This is in the same room. It's in the same pressure, same temperature, all that stuff. And yet we have some plastic, which is a solid. There's some, this liquid, the soda is a liquid. And then in between here, we have some air inside the bottle. There's some air molecules that are acting as a gas. So even though they're all the same temperature, one's a solid, one's a liquid, one's a gas, right? Well, how is that? Well, it goes back to those forces between the molecules. And so what we can see is some molecules are more attracted to each other, and we call that intermolecular forces. So they're attractive forces that occur between the molecules. So let's be careful here. We've talked a lot about bonding lately, right? So O and H are bonded together as one molecule. Intermolecular forces are the forces between different molecules. So this is a water molecule and this is a water molecule, and there actually is an attraction there that kind of keeps them together. So because water has some attraction to itself, it can stay as a liquid at room temperature. Here's another example. This is a horrible example, by the way. I don't know where I found this picture, but you can see that these people don't know their chemistry too well. Look at this water, O2H, horrible. But the point is, these are bonds. The solid lines are bonds. That's not what we're talking about today. We're talking about some attraction between the molecules. And molecules can have different strengths of that attraction. So if we think about it, just like our magnets and our marbles, if there's a lot of attraction, it's a solid. If there's a medium attraction, or it's just kind of a little bit of attraction, there's a liquid. And if there's almost no attraction at all, then there's a gas, right? So we can determine now our intermolecular forces. So let's try to see which one has the most and least intermolecular forces, right? So again, we have our plastic, we have our air inside, and we have our liquid soda. Well, we just said that things with really, really high attractions, like our magnets, stay as a solid. So out of these three, the one that's most likely to have the highest intermolecular force is the plastic. That means each of these little plastic molecules inside this bottle are really attracted to each other. That's what keeps them as solid at this temperature. So the next one then, the least molecular forces would be like our marbles. They have no attraction to each other, so they make a gas. That's like the air inside this part of the bottle here. So inside that bottle, those molecules are just floating around freely, just dancing around like gas molecules. So they have the lowest intermolecular forces. And then right in the middle between those is our liquid. They're attracted to each other, but they're not attracted to each other super strongly. So they can actually flow around and move past each other and slide like liquids do. And so they have medium intermolecular forces. And so you can tell just by looking at something if it has a lot of intermolecular forces or not, right? Anything that's solid, high intermolecular forces, gases are low, and liquids are kind of in the middle between them. And that's the basic fundamental idea of intermolecular forces. If you understand all that, you are good to go.